This is Harren Appleman from Santa Monica once again with the third edition of Nakamichi Spoken Here, our fall 1975 edition. In this edition, I'd like to deal with two topics. Number one, a certain rumor which originated in the New England area about our machines, and number two, I'd like to discuss a little bit with you about the Nakamichi heads. First of all, the rumor is this, that the Nakamichi 500 is basically the same machine as our previous OEM products. OEM stands for Original Equipment Manufacturer, and it just means those products which we manufactured under other brands. Now, this is absolutely not true. The transport of our 500 may look similar to other things we have made in the past, but that's all. It looks similar, and the similarity ends there. As I mentioned back in our first edition of Nakamichi Spoken Here, Nakamichi Research started cassette work in the mid-60s. The very first model which we mass-produced was for Lafayette Radio. That was really the first generation of machines. The second generation was the machine we made for Harman Kardon, the Harman Kardon CAD 4. The third generation, the Fisher RC70, and the fourth generation, the Advent 200. Now, the transports used in the first through fourth generation machines is most likely very familiar to many dealers. The transports were not exactly the most reliable in the world, and they were not exactly the most sophisticated in the world. For example, the pause was an electric pause, not mechanical like it is today. That is to say, the pinch roller remained engaged in the pause mode. Now, with the fifth, sixth, and seventh generations, and of course, with each successive generation, there's a certain degree of improvement. Now, fifth through seventh generations were comprised of machines that we made for Harman Kardon, the CAD 5, Fisher RC75, RC80B, Motorola, Sylvania, Concord, ELAC, Wharfdale, and several other European brands. It's with the 8th generation that we began manufacturing our own, we began offering the Nakamichi brand two-head cassette machine, the Nakamichi 500, and this was around 1974. It's about that same time that we perfected the focused gap head, which of course is incorporated in the Nakamichi 500. With the Nakamichi 550 came the 9th generation of improvements in the transport design, and today's Nakamichi 500 and 550 are 10th generation machines. In those 10 years, we made and sold close to 500,000 units, and of course, needless to say, we gained a lot of experience. Today's transport that we use for our two-head machines, of course, we still get some complaints about buttons. About the buttons, they're hard to push, they're not easy to find, so forth. And those complaints, by the way, aren't falling on deaf ears. We're taking all these things into consideration. But the thing to remember is that the mechanical transport is a completely debugged mechanism. We've got it to the point where the cost versus performance is excellent. It allows us to offer machines such as the Nakamichi 500 and 550 at prices which, from the standpoint of performance, must be considered low. Starting with the 8th generation, and like I mentioned, that's when we started a Nakamichi brand with the two-head machines. The following improvements were incorporated that were not found on previous generation machines. Number one, the focused gap head. I already mentioned that. Number two, the motor and drive system is completely different. It's a DC servo control system. Number three, the wow and flutter is much lower, thanks to precision capstan and flywheel assembly. And number four, the tape traveling has been improved thanks to new head and guide mounting methods. And number five, the electronics in the Nakamichi 500 and 550 are completely different. And they're much improved thanks to ingenious new circuit designs and the availability of lower noise and higher performing semiconductors. Since we introduced our own brand in the United States, we have done no OEM work in the U.S., and we do not intend to do any in the future. We do not even sell our heads to other manufacturers. There have been some rumors that started mainly by other manufacturers that they use Nakamichi heads, but that's impossible because we do not sell our heads to anybody. Another rumor that I've heard recently is that Nakamichi buys heads from a head manufacturer. This is nonsense because, well, the fact is that there are only 4 tape deck manufacturers in Japan at the moment who manufacture their own heads. And those 4 are Sony, Akai, Panasonic, and Nakamichi. Now, of these 4, only Akai and Nakamichi use heads exclusively for their own machines. Akai and we do not sell our heads to other manufacturers. And of the 4, only Nakamichi uses metal heads. All the other makers use ferrite heads exclusively on their best machines. But Nakamichi has never used a ferrite playback head or a ferrite record playback head. And of course this leads naturally to a question that I often get, what's wrong with ferrite? Well, I'm glad you asked me that because I want to tell you what's wrong with ferrite. About 2 years ago, a number of the leading tape deck manufacturers made a big push for ferrite. They spoke as if ferrite heads were the only heads worth considering. We think that they grossly misled consumers. To explain why, I'm going to have to get somewhat technical to really appreciate the following discussion. It requires a knowledge of magnetics, hysteresis curves, and so forth. But since this isn't a technical bulletin, I will try to keep it as simple as possible. It is our view that ferrite can't be successfully used for playback heads in the case of 3-head machines, and record playback heads in the case of 2-head machines. Manganese zinc ferrite, ever since its development, has been applied to magnetic heads, but this substance has the following magnetic properties. Number 1, the B sub R, or the Bmax, which is the maximum flux density, is less than 4 kilogauss for ferrite. A regular high mu metal head has a Bmax of over 12 kilogauss. Number 2, the H sub C, or the coercive force, is 10 times greater for ferrite than it is for high mu metal. Now, when ferrite record playback heads are used in 2-head machines, and a record playback head, since it is a compromised head, has a relatively narrow gap. In the record mode, such a head would suffer from the following: the low Bmax, the maximum flux density, means that the head will saturate long before the tape will. And that is to say, the magnetic penetration is poor. Even the best ferrite record playback head will saturate 5 to 6 dB earlier when recording than a high mu metal head counterpart. Furthermore, manufacturers using these heads will try to forcibly increase the flux by increasing the record current to the head, figuring this will compensate for the poor penetration. But all this does is raise the operating temperature of the head, and this further degrades the performance. Now, when playing back with the same record playback head, you have these problems. You have to remember that the playback process involves some 40 to 60 dB less energy than the record process, and this is because in record you're magnetizing the tape, but in playback you're picking up signals off the tape, so it's a much lower energy process. Number 1, now since ferrite has a high coercive force, the H sub C, your mu sub naught, which is the initial permeability, is highly nonlinear. You have to look at the ferrite head and ferrite's hysteresis curve to really understand this. But the point is that there is a nonlinearity in the initial permeability. Now, although a high mu metal head also has the same nonlinearity, it's not nearly as bad as it is for ferrite. The result of this nonlinearity is, well, you can hear it. If you play a tape over a ferrite head machine and compare it to, for example, the sound you would get when you play back the same tape over our Model 500, you'll find that the ferrite will sound muddier. It's a form of distortion. This is due once again to that nonlinearity. Number two, now ferrite is very porous. That is to say, it has a lot of small holes in it, and these random holes act as random dummy gaps, and these cause random noise. Number three, another side effect of the high H sub c, the coercive force, another side effect exhibited by the ferrite is the buildup of residual magnetism. Now, there are many stresses imposed on ferrite material when it's cut. On top of that, the high temperature process of melting the crystal glass into the gaps, this also adds stress. Now, after cooling, the ferrite is under constant stress because of the differing coefficients of expansion of ferrite and crystal glass. Ferrite and the crystal glass expand at different rates, expand and contract at different rates, and so the head itself is under constant stress. So what happens is this. Now, it used to be believed that only physical shock can put a magnetism in the ferrite material, but because of these constant stresses, which I just mentioned, a ferrite head can actually build up on its own. It can build up DC magnetism just by sitting there without using it, without playing back any tapes over it, because of fluctuations in ambient temperature. Now, since the record playback head has a narrow gap, this DC magnetism gets applied to the tape at a high enough flux density to partially erase the tape. Usually your high frequencies become attenuated. And this is why you should always demagnetize ferrite record playback or playback heads before playing valuable tape over a machine which has a ferrite head, even if the machine was demagnetized a while ago and it hasn't been used at all since the previous demagnetizing. Now, there are some good points about ferrite. For one thing, it's a single block, and there's no laminations necessary, so that quality control and manufacture is a little bit easier. Also, the ferrite heads are resistant to wear, and it's a harder material, so that they will not wear as quickly. But it is not a long life head in this sense. The gapping process of ferrite requires rough treatment, such as high temperatures for melting the crystal glass. Now, after the initial cooling, during the aging process, cracks form on the edge of the gaps. The glass pulls away pieces of the ferrite core material, and the edges of the gap become very uneven and zigzag-shaped. This can't be seen on these lovely close-up photographs of ferrite heads that you often see in advertisements, but you can see this uneven zigzag-shaped gap. You can see this if you look at the head under an electron microscope. What this does is it drops the permeability of the head by as much as by a factor of 10. Then the effective gap becomes much wider. So what you get is the head performance degrading with age, independent of use. So in that sense, a ferrite head is not really a long life head, and it's for these reasons that I mentioned that the high mu metal heads are better than ferrite for the record playback head. Now, going to 3-head designs, the erase and record heads use much wider gaps because a smaller gap is not as practical for high energy applications. Now, since the gap width is about the same as the tape thickness, high flux density is not required, and as was the case in recording with a combination record playback head. The combination record playback head has a narrower gap, so high flux density was required. But when you have separate record and playback heads for both the erase and the record head, you do not need high flux density because of the wider gap. And so for these applications, ferrite is almost ideal. And this is why Nakamichi 3-head decks use ferrite record heads, and all Nakamichi machines use ferrite erase heads. The initial nonlinearity of the permeability, due to the high coercivity that I mentioned, is not a problem in a ferrite record head because in record, you operate outside the nonlinear portion of the hysteresis curve. You operate in a linear region, so the nonlinearity that I mentioned before, which becomes a problem with your combination record playback head, is not a problem in your wide gap record only head. Although you still have DC residual magnetism effects, it's not critical because the gap is much wider, and therefore the flux density is much lower. Roughly speaking, there's an inverse square law at work here. 5 times the gap width equals 1/25 the flux density. Since high flux density is not a requirement in wide gap record heads, record and erase heads, with proper design, we can keep the operating temperature low and thus maintain constant performance. Also, the porosity of ferrite, the random holes, is not a problem in wide gap applications because the energy level, as I mentioned before, is 40 to 60 dB higher in record than for playback. Our record head is a unique ferrite design. It is virtually a single macro crystal. It has improved maximum flux density and initial linearity. So, to summarize, in 2-head machines where you have one narrow gap head for record and playback, in the record mode, the ferrite head has higher distortion because the saturation point is much lower than for conventional high mu metal heads. And furthermore, in poor designs, the operating temperature increases, further degrading the performance. In the playback mode with the same head, the initial nonlinearity due to the high coercive force in the case of ferrite causes distortion. It causes a muddy sound. Because of the low energy levels in playback, the random holes in ferrite cause noise. The high coercive force and small gap causes self-building DC magnetism to erase high-frequency information on tape, unless the head is very frequently demagnetized. Deformation of the gap with aging widens the effective gap, degrading high-frequency playback performance and signal-to-noise ratio. But for erase heads and for record-only heads in 3-head designs, where the record and playback heads are separate, and since the gap is much wider, ferrite heads can be designed to provide excellent performance and low head wear. So this once again leads to another question. So what does Nakamichi use for the record playback head in their 2-head machines and the playback head in their 3-head machines? Well, most of you know about our crystal permalloy focus gap head that we use for the 500 and 550, and we use a similar head for the playback only in the 700 and the 1000. These crystal permalloy heads have a long history of development. They were not developed exclusively for audio applications. The crystal permalloy material was developed by a Dr. Masumoto of the Institute of Metal Technology, which is a part of Tohoku University in Japan. Dr. Masumoto is one of the leading metallurgists in the world. One of the things inventions he's known for is a mainspring, which is now in use in all your Seiko watches. This mainspring will not expand or contract with changes in temperature. But anyway, going back to heads. The crystal permalloy is an extra high mu metal. Its hardness is over 220 degrees on the HV scale. The regular high mu metal head is about 100 degrees. Regular high mu metal is an alloy of nickel, manganese, and molybdenum. The crystal permalloy has those metals, but in addition it has niobium and titanium. We use a special heat treatment in a hydrogen furnace that minimizes the stress while maximizing the magnetic performance and the stability. In using this crystal permalloy for our heads, we use a chemical photo etching process instead of the usual stamping methods. And that's not as easy as it sounds. Crystal permalloy requires a special fluoride compound to photo etch the metal. But this compound melts away any standard photo etching machine. So it took us about 2 years to get over that problem and to perfect the process. We minimize mechanical stress in assembly right down to the last step. All the cutting and polishing is done with diamond. What we've come up with we think, is something very close to the ideal head. There are a couple other things about the crystal permalloy heads. If you take a close look, you'll notice that our shape is a little different from other heads. It's a special shape that minimizes contour effect. What's contour effect? For those of you not familiar with it, it's you may have noticed it in most. You will notice it in most cassette machines. It's the peaking and dipping of lower frequency response. It's like a damped sine wave, and this results from dummy gap effects. The edge of the head, where the head falls away from the tape, the shoulder. The contour effect is also called the shoulder effect for this reason. Acts as a dummy head. These shoulders act as a dummy head, and then you have your various resonance and anti-resonance modes resulting from these shoulders. What we've done is we've shaped the head to minimize this effect. Now, all machines have contour effect, even open reel. It does become more pronounced at lower tape speeds, but you'll notice some cassette decks in their frequency response curves, they show no contour effect at all. In that case, you can bet that the playback circuitry contains equalization, usually LCR circuitry, to tune out the contour effect. But this colors the sound, since such circuitry invariably introduces gross phase shifts, and low-frequency coloration of this type is really quite audible. So what we've done instead is gone to the source of the contour effect itself. We've changed the shape of the head to minimize this effect, minimize contour effect to the point of inaudibility. One other thing, our head is actually alive. It breathes. This is important because it means the head can adjust the temperature and give you constant performance. For really a detailed discussion of this whole business with heads, we suggest that you look through our Nakamichi Technical Bulletin number 4. That's all for this time. As Mr. Nakamichi mentioned in Nakamichi Spoken Here number 1, I'll be stationed in Europe, in Rotterdam, the Netherlands, to work for our European operations for a while, starting this fall. In fact, by the time you hear this tape, I may be there already. But I hope to keep bringing you these news cassettes, no matter where I might be. So please write to me, Harron Appelman, with any questions, any rumors, any anecdotes, so forth. You can always reach me through our Santa Monica office. The demonstration tape this time you'll find on the reverse side of this cassette is brought to you courtesy of Jonas Miller Sound, Ken Kreisel of Jonas Miller Sound. Jonas Miller Sound is one of our distinguished dealers in Beverly Hills, and Ken Kreisel is the man behind the recordings, selections from which you will find on the other side of this tape. Jonas Miller and Ken Kreisel formed a recording company called Miller Kreisel Sound Incorporated, and they put out, among other things, direct disc recordings. They've put out a number of 45 RPM discs. We hope that other dealers will start, dealers who don't do so already will start making their own live recordings using our Nakamichi microphones and our equipment, or whatever equipment you have at your disposal. But we think this is very important, and hopefully we can encourage some kind of exchange among our dealers of live recorded material. And of course, if we'd always welcome any tapes that any of you dealers come up with that you think might be alright, might be good for us to use selections from in the Nakamichi Spoken Here demonstration tapes.
tancowała by so, bosa są. Kup mi liczysz mi, twoja są. A kiedy mi liczysz mi, nie kupisz, nie wiem cię lubić, nie wiem cię poskać widzisz. A kiedy mi liczysz mi, nie kupisz, nie wiem cię lubić, nie wiem cię poskać widzisz. Hej, koniczki moje, do skoku. Budem leżać milej, holubiczkę sywej, przy boku. Nie budzę się modlić o ciele, kolko raz mamila, holubiczka sywa, poboskać. Nie budzę się modlić o ciele, jej kolko raz mamila, holubiczka sywa, poboskać. Tancowała by so, bosa są. Kup mi liczysz mi, twoja są. A kiedy mi liczysz mi, nie kupisz, nie wiem cię lubić, nie wiem cię poskać widzisz. A kiedy mi liczysz mi, nie kupisz, jej, nie wiem cię lubić, nie wiem cię poskać widzisz. Пойдемте, друзья, ведь завтра в поход уйдем в предрассветный туман. Споем веселей, пусть нам подпадет седой боевой капитан. Прощай, любимый город, уходим завтра в море, и ранний порой мелькнет за кормой знакомый платок голубой. На вечер опять легла тишина, что песен не петь нам нельзя. А в службе большой, в дружбе морской потянем дружнее, друзья. Прощай, любимый город, уходим завтра в море, и ранний порой мелькнет за кормой знакомый платок голубой. Прощай, любимый город, за кормой знакомый платок голубой.
It's a little less than ideal.